Hey, how's it going? Today I'm going to go over valid parentheses. This is seems to be a pretty popular problem right now, and I'm just gonna go into like how I would treat it during an interview. All right, let's get into it. Um, okay, so first step, I'm going to just read the problem. Given a string S containing just the characters where we have different kinds of parentheses and brackets, determine if the input string is valid. The input string is valid if open brackets must be closed. Open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. Okay, so I guess with those conditions, we're sort of dealing with the values that are going to have like parentheses and brackets, and then they would have to just match up in terms of where they're opening and what they're closing. So like for this case, we have opening parentheses and then a square bracket, and so we have to close the square bracket before we close the closing parentheses. Yeah, I guess if there was an empty string, I would assume that is still a good string, so that would return true. So yeah, I've actually done this problem before. So like how I would envision this is go through like some of the examples. So when we have two parentheses here, so I have like a open parenthesis, so I want to make sure I close it. I'm looking for a closing parenthesis. If I have an open parenthesis here, I'm looking for a closing. I'm open bracket, I'm looking for a closing. And if I have two of these guys where they are different, I would want to make sure I'm looking for the most recent before I look for the later ones. And then that pattern also follows. So say I have like this, and that, and then that, and then maybe something like this again. I'm going to go through this starting from the end of it. So we need to make sure that we end with a parenthesis, a curly brace, and a square bracket. And then when I get to this point, I have like another parenthesis. So I'm looking for a closing parenthesis. This is my most recent at least. So if I come into this side, I have a most recent where our parentheses, so that'll close out, so we can get rid of that, right? And then we'll have the continuation where we have the curly braces now, or no, sorry, the square brackets. And from then on, we're looking for another closing square bracket. And then following that pattern, we'll eventually get to the end of it. And say we have one of these eventually be like a parenthesis, then we would know this is invalid. It's because when we get to this point where we're removing that, we'll have these over here, the curly brace, and then we're looking for another curly brace. And since we aren't able to close this one out and we find something else, we know that that will be false. And with those in mind, I mean, like we could possibly like maybe use, I'm just gonna go through like the different options. So like say you're thinking maybe we can use a hash map to like indicate the values. I mean, yeah, that could be fine depending on how you structure it, but we need to retain the order, and that could be annoying to work with if you're trying to use key value pairs where maybe the key is the bracket type, and then the value could be like the indexes. That'd be really could work. It could work. It would require a lot of logic within it. And then there's other data structures. I mean, trees and those other graph stuff like seem pretty irrelevant in this case, since we're just looking to go through and we're going through the string in a one pass, and then as we get to the other end of it, we're just going to be removing, right? So with that kind of thinking, I mean, like it would come down to like using a queue or a stack. Can we use a queue? Probably not, because we were talking about how we wanted the most recent to be removed. So if you remember how these structures, these data structures are, stacks are first in, last out, and queues are first in, first out. And since we want the most recent one that we added, a stack would be perfect for this kind of problem. So why don't we do something like that? So we'll have stack is equal to this. I don't use the data structure in this case. I mean, I treat this array as the stack. I'm sure there's better, more optimal ways of doing so, leveraging linked lists, but for this problem, I'll just treat this as a stack. So pretend this is constant time in pushing and popping. All right, so then now we'll go into our for loop. I'm going to do for const c of s. So this is just iterating each character within our stack. And let's do if, so we want to check for all the possible scenarios, right? So the possible ones will be open bracket or open parenthesis, else if c is equal to open bracket. Let's see, so I guess in this, we're probably only dealing with parentheses, right? Just kidding, yeah, okay, so I don't, so in this case, I can just do an else. So this would be the, or the square bracket case. So what I'm trying to do here is every time I find these characters, then I want to push them in. Well, I guess in this case, I don't really actually care for the opening one, because the opening, I just want to add it into it, right? So let me try to redo the logic. So instead, I actually want to do c is equal to closing, the closing brackets. So that way I can compare it. Actually, do I need to do this comparison? I could probably just check the stack to see if it matches, but it would need to be a closing one. So as long as it's a closing one, yeah, okay, so I think that makes sense. So have that, else we're just going to do stack.push of c. So the else case is for if it's an opening, but if it's a closing, so we'll do if c is equal to a closing parentheses, if stack, we'll do stack.length -1, the very last index, the most recent that we added. If the last is equal to what you call an opening parenthesis, then we'll do a stack.pop. This is to remove the most recent, and this logic is continued with all the other cases. But say for some reason, yeah, I mean, there's probably a way to optimize this, but this is, let's just keep it simple for now. So this one I'm looking for the opening curly brace, and this one I'm looking for a square bracket. And so once we iterate all the way through the string, if these conditions aren't met, we're going to have a stack that has values within it, right? If we would know our string is, what's it called? Correct if our stack is empty at the end of the whole iteration. So we'll do a return stack dot length is equal to 0. This is just a comparator, so if it is equal to 0, then we'll return true. But if it's more than 0, or yeah, I mean, the only case it can be more than 0, then it'll return false. So this solution probably works. Okay, yeah, but there are points where you can optimize it. Try to take a second here to think about what you could do. Let's see. So for in this case, if I find if that one of these conditions don't succeed, I could just fail out of it, right? I am going to a case where I would have to write else return false. But now I'm kind of just writing that for every single one of these cases. And that makes it very, I mean, it's, I don't know, it's not very clean. It's getting to a point where I could easily modularize this, and I feel like during an interview, if you have time, try to explain that or try to maybe even implement it. So say we have this case, right? So I'm going to write another function. Let's call it check. We will pass in the character. And since our stack is here, we don't have to worry about that. So I can keep this logic in there. So we'll do this. And for this case, I want to, after that is done, we're going to return true. And the reason being for that is because I want to do it this way. So I'll do if check, what character are we looking for? We are looking for, I'm going to pass in the opening of each case. So I have this. If check returns false, then we want to return false. So now I'm able to go through each character, and if we find the case where it doesn't match, we can fail out quicker. And I'm not having to replicate this if statement everywhere. I can simplify it into this kind of process. So now I can do this here as well. So it'll be the square bracket. There's probably more ways to optimize, or not optimize, but yeah, modularize this. I kind of don't want to go into that because, I mean, I have to think about it a little bit more. But this is kind of just like a general solution, and this is pretty clean. Like I would probably take this. Let's see. Yeah, so that one still passes there. So let's try submitting, and we got a pretty good test, or got a good completion. Then you have to think about like the time complexity. I haven't done this for the other videos, and I feel like it would be good for this because most of the time you'll be asked the different complexities. So say I'm looking at this, right? So I'll come into this first for everything how we set it up. So we have our stack. This will eventually populate up to a size of n/2, or in the solid case at least. But if it's one of those bad ones, it could populate to n, which both n/2 and n simplify to order n. And then we have our check function. This one, in this case, it would be, I mean, the length property is calculated on the fly, so that's constant. But then also if this was a legitimate stack where we're using like a linked list, all of these operations would be constant. So that can also be relayed to your interviewer or to yourself when you think about it. Just say, hey, yeah, I mean, this would be constant time, and if we had like a better stack, but this works perfectly as well. And yeah, all of these operations are all constant. So now we come into this side where we're doing an iteration on C of S. This would be order n since we're iterating through each character, but we are failing early. But that doesn't really matter. We're thinking about like the average or the worst cases here. So this would be iterating through the whole string. Or I guess in this case it would be the average or like best cases. And so Wait, I guess I don't know which one it would be. I mean, I'm saying best case in terms of like it succeeds, but then there's also the worst case for time complexity where it does succeed. So I guess just be clear on what you're trying to relate to your interviewer. So yeah, now if we come into these checks, these are all constant, so we don't have to worry about that. Plus the stack push is also constant. So what we come down to is our time complexity is order n, and our space complexity is also order n, because of our stack and how we populate that. And yeah, that is it. That is the problem. If you have any questions, feel free to leave a comment. Otherwise, yeah, if you like the video, leave a like. It helps a lot. What else? Yeah, thanks for watching. Bye.